Hello everyone, Mr. Miller here. Hope that you're doing well. I'm making a short video today on the June 2023 paper 3 video, which I set you for homework. That is due this Friday. I've only got time to go through a few questions. I'm going to go through 8 of these questions. These are the ones that I think you will find the trickiest. So let's go ahead and start off with question number 6. Okay, so this question was about lava flowing from a volcano at a constant rate of 11.9 meters cubed per s is second. So that's important, per second. Then it says, how many days does it take for 67 million and something meters cubed of lava to flow from the volcano? Give your answer correct to the nearest day. So there's definitely going to need to be a conversion between seconds and days. So I'm just going to write down some things that I know. First of all, how many seconds in a minute? Well, there's 60 seconds in 1 minute. And from minutes, I need to go to hours. So there's 60 minutes in 1 hour. And then from hours, I can go to days. So there's 24 hours in 1 day. So I'm going to need to use all of these conversions at some point. So how do I go from the total amount of lava, which is meters cubed, to how long it takes? Well, if it takes 11.9 meters cubed per second, to find out how many seconds it's going to take, I think I need to do this big number here divided by 11.9. And that's going to give me my time, which is 5 million. This number here in seconds. So that is the time in seconds. Now, how do I convert that time into days? Well, I need to use the conversion ratios I've already worked out. So I need to divide by 60 for the time in minutes, divide by 60 again for the time in hours, and finally divide by 24 for the time in days. And that ends up being 64.36 something, and to the nearest day, 65. So really the key in this question was, first of all, working out how I go from seconds to days, step by step, and second of all, how I go from my meters cubed to my time in seconds. Next question I'm going to have a look at is, I think, question 11. Okay, so here is question 11. You saw a very similar question in your mock. This was the similar question to your similar paper to your mock. So part A was to draw a box plot for the information in your table. Now, you need to be really careful when you're plotting this, because although usually when you plot a box plot, it's a really easy 2 or 3 marks. Here, you need to be really careful with the key. So if I just take this gap there between 155 and 160, that is a gap of 5, but there are 10 small squares. So you need to be really careful that each small square, or 2 small squares, makes a gap of 1. So when you are plotting your least height, you might make the mistake of plotting it here. But that would be wrong, because it needs to be 2 small squares away from 170. So that is 169. My greatest height, 186, so it is there. My median, that's going to be 4 small squares away from 175, so that is there. My lower quartile and my upper quartile there. And then I join them together to find my box plot. So just be really careful with your key on that question there. Part B, I'm going through this question because we haven't seen a question like this for a while. It says compare the distribution. Compare the distribution. Now, this is always going to be a 2-mark question. Really, really common that it comes up. You need to do 2 things. First of all, we need to compare the median. So we're going to say the median. Well, the median is 177 for the adults. what is it for the teenagers? It's lower, it's 169. But all we need to say is the median is higher for adults. We don't need to give any numbers, but we're going to make a contextual comment. This means that in context, if the median height is higher, then this means that adults are taller on average. So that's the first mark. The second thing that you need to do is you need to compare the interquartile range. So the interquartile range, so that is the upper quartile minus the lower quartile, remember? So for the adults, the interquartile range is the gap between those, 180 minus 174, which is 6. And here, it looks like that gap is also 6. So we can say that the interquartile range is the same for both. We don't need to make a contextual comment for the interquartile range. We could if we wanted to, but we only need to make a comment in context for one of the median or interquartile range. So I like to do it with the median. It's just a bit more straightforward. Okay, let's move on to the next question. Okay, this I thought was a really challenging question. It says an expression for the nth term of the sequence of triangular numbers is n brackets n plus 1 over 2. Prove that the sum of any two consecutive triangular numbers is a square number. Now, a few people already asked me about this question. They were like, so what is a triangular number? Now, you don't actually need to know what a triangular number is for this question because it gives you the formula. What you do need to know is what two consecutive triangular numbers are. Now, if I asked you what two consecutive numbers would be, you would just tell me it would be n and n plus 1, and the next one would be n plus 2, etc. So the next one is just adding 1 to it. So you're going to do the same thing for triangular numbers. Your first triangular number is n brackets n plus 1 over 2. And because it says sum, I add. Your second triangular number, instead of n, you're going to write n plus 1. So let's just change color there. I said instead of n, we're going to write n plus 1. So that n becomes n plus 1. And n plus 1, well, if I add 1 to that, what does it become? It becomes n plus 2. So that is an expression for the sum of two consecutive triangular numbers. What's our next step? Well, our next step is to expand and simplify this. So the first one is n squared plus n over 2. I just expanded brackets there. And then the second one, I'll just do a box to help me. The second one is n squared plus 3n plus 2 over 2. Now, if I add those together, I've got n squared plus n squared, which is 2n squared, n plus 3n, which is 4n, plus 2. And you should be able to notice that I can divide all of these terms by 2. And then how do I show it's a square number? Well, a square number is something squared. And you should be able to realize that I can write this as n plus 1 squared if I factorized it. So that was a super tricky question there. But the key learning is that consecutive means instead of n, you write n plus 1. Instead of n, you write n plus 1. Let's keep going. A few more questions left. Okay, question 15. This was the question from the mock, at least in part B, that no one in the U group got right. So let's go over it. Part A, lots of you got right. A squared minus b squared. You realize that this was the difference of two squares, which we've done in today's lesson, actually. So you should all be able to say that this is a plus b, a minus b. Now, part B, show that 2 to the power of 40 minus 1 is the product, okay, so that means multiply, of two consecutive odd numbers. Now, what am I going to do here? So the first clue in this question is that part A was a difference of two squares question. So part B, you should be thinking, could I do difference of two squares? Okay, well, how would I do this? Why is this difference of two squares? Well, if you actually think about it, 2 to the power of 40 is what times by what? Can you think about it? Well, if you were thinking 2 to the power of 20 times 2 to the power of 20, you would be right. Because when you multiply indices with the same base, you add the powers. So I can actually write 2 to the power of 40 minus 1 as difference of two squares, where the first term is 2 to the power of 20, and the second term is just plus 1 and minus 1. Okay, now the next thing that we need to think about is odd numbers. So two consecutive odd numbers. Let's think about this. Let me use a different color. So let's first consider 2 to the power of 20 plus 1. Well, let's think about 2 to the power of 20. 2 to the power of 20 is 2 times 2 times 2, etc., 20 times. So it must be, it must be even, because anything that has been times by 2 is even. Therefore, or so, 2 to the power of 20 plus 1, if you add 1 to an even number, you're going to get an odd number. Now, if you think about the second thing here, well, that is also going to be odd. And if we think about three consecutive numbers, where I've got 2 to the power of 20, 2 to the power of 20 minus 1, and 2 to the power of 20 plus 1, you should be able to see that the two that I've got here, I can say that these are two consecutive odd numbers. Because one is 2 to the power of 20, the next one is 2 to the power of 20 minus 1, so one below it, and then the 2 to the power of 20 plus 1 is one above it. So, because they're both odd, they're both next to each other, they're two consecutive odd numbers. Next question. Okay, question 18 was a question about a frustum for 5 marks. So let's get into it. A frustum is made by removing a small cone from a large cone as shown in the diagram. It tells me the slant height of the small cone is 6, slant height of the large cone is 10, the radius of the base of the large cone is 3, and it asks me to find the total surface area of the frustum. Okay, so the first thing I notice is that I've got all the information that I need, but one thing I don't have is this radius here. I don't have that radius. So I think my first step is to find my radius of the smaller cone. Now, you might remember doing this, that whenever I've got a frustum, I need to use scale factors because both of the cones are similar to each other. So I'm thinking, how do I get from the large cone to the small cone? How am I going to get from 10 to 6. Well, I think I'm going to multiply by 6 over 10. To get from 10 to 6, I multiply by 6 over 10. That can be simplified if I want to as 3/5. So to get my smaller radius, I'm going to do 3, which is my big radius, times by 3 over 5, which in your calculator, let me just get my notes, in my calculator is 1.8 centimeters. Okay, so that gets me my first mark. Now, my second mark is going to be to start finding my surface area. So let me get my highlighter out and let me actually highlight the surface area. I'm going to start off with this bit in yellow here, that bit in yellow. Okay, so that bit here is not the whole surface area, but that bit there is the curved surface area. That's the bit kind of around the outside of the frustum. Find the curved surface area. So to do that, what you need to imagine is finding the area of the whole cone, the big cone, and then taking away the smaller cone. So the surface area of the whole cone is pi big R times big L minus pi r little l. Let's substitute that in. So the radius of the big cone is 3, the length of the big cone is 10, and in the smaller cone, the radius was 1.8, I found that, and the length was 6. And if you put that into your calculator, you get 19.2 pi. You could also have that as a decimal. Now, that is not actually your answer. That is only how you get your second mark. Because one thing that you can't forget, and I'm going to shade it in a different color, is that the surface area is the total area around the whole shape. And what I haven't shaded, in green I'm shading now, are these two circles on the top and on the bottom of the frustum. So my third step is to find the area of the circles. That's actually quite easy because it's just pi times radius squared. So I'm going to do pi times 3 squared. That is the big circle at the bottom. And then the smaller circle, pi times 1.8 squared. That gives me 12.24 pi. Once I've done that, I've now worked out the total, and I can add together 19.2 pi plus 12.124 pi, which gives me 98.8 centimeters squared. So just to go over that one more time, my first step, I usually have to do this in a frustum question, is to find a missing length using scale factor. My second step was I found the curved surface area by taking away the small cone from the big cone. My third step, I added on my two circles. And then my fourth step, I added the two bits together. Tricky 5-mark question there. Let's move on. Question number 21. This we did in class today. So hopefully, actually Plymouth, we are doing this tomorrow. Cambridge and New York, we did this today. So solving equations with fractions. This was a question that we all struggled with in the mocks, or a lot of us struggled with, but we are revising it and we're going to go over this question now. So it says solve an equation. Now, when I've got a fraction, my first step is to think about what my common denominator is. And when I've got some algebra in the denominators, I just need to multiply the two denominators together. So that is my first step. That is my common denominator. And I'm not going to forget equals 1. Now, I now need to decide what my numerators are. So if I think about what I need to do to get from x plus 4 to x plus 4 2 minus 2x, I think I need to multiply by 2 minus 2x. So my numerator, my first numerator, is going to be 1 brackets 2 minus 2x. That kind of makes sense, because if I imagine cancelling out that 2 minus 2x, I'm left up with 1 over x plus 4. Okay, next one. What am I going to multiply the 3 by? Well, what's missing is the x plus 4. So I'm going to multiply it by that. Okay, next step, I'm going to simplify the numerators. So I've got 2 minus 2x plus 3x plus 12 all over x plus 4, 2 minus 2x equals 1. Now, in my next step, I know I need to collect like terms. So I've got minus x, not minus x, plus x, sorry, x, because minus 2x plus 3x is x, plus 14. And here I'm actually going to expand the brackets in the denominator. I'm going to have to do this at some point. I'm going to do it now. So I'm doing this up here. So I've got minus 2x squared minus 6x plus 8 equals 1. Now my next step, I'm going to cross multiply. So what do I have? Let me write it up here. I have got minus 2x squared minus 6x plus 8 equals x plus 14. Okay, now I know that this is a quadratic equation. I need to think about what side I'm going to move everything onto. Now, I'm going to highlight this minus 2x squared. I actually don't like having a negative x squared. I'm going to want to move that onto the other side, so it is a positive x squared. So I need to move everything on the left-hand side onto the right-hand side. So I've got 0 equals 2x squared plus 7x plus 6. Okay, almost there. I now know what to do. I'm looking for two numbers that multiply to give 12. 2 times 6 is 12. And add to give 7. Those numbers are 4 and 3. So I've got 0 equals, splitting up the 7x. We've done lots of this recently. So I'm just doing the normal method. And to get my answer, I need to find out my x1 and my x2. So my x1 is going to be minus 2. And then my second solution, I need to make that bracket equal to 0 and solve that equation. So 2x equals minus 3, x2 equals minus 3 over 2. So I'm going to make really clear to my examiner what my answers are. x1 equals minus 2, x2 equals 3 over 2. So hopefully you managed to be successful with that. I think the tricky part here was realizing when I had this minus 2x squared, it's much easier to bring that onto the other side because you want your coefficient of x squared to always be positive. Okay, let's keep going. Question 23, 2 more questions to go. A circle has equation x squared plus y squared equals 25. The point P with coordinates minus 3, 4 lies on the circle. Alex says that the tangent to the circle at P crosses the x-axis at the point minus 8, 0. Is he correct? So my answer needs to be yes or no. And what do I need to find? What do I need to work out? I think I need to work out where the tangent, I need to work out where the tangent crosses the x-axis. And then if I agree that it's minus 8, 0, I'm going to say he's right. If I disagree, I'm going to say that he's wrong. Now, with these questions with circles and tangents, I always tell you these are difficult questions. And if you don't draw a diagram, you're going to find them a whole lot more difficult and confusing. So I'm going to draw a diagram. I mean, it's just so hard to do it without a diagram. I'm going to draw in my circle. And now I need to think where my tangent is. So the point P with coordinates minus 3, 4 lies on that circle. So I think that point is somewhere minus 3, 4 up here. So therefore, I'm going to draw in my tangent like that. That is my tangent. This is my point P with coordinates minus 3 and 4. Okay, so whenever I'm doing these questions with circles and equations, before I worry about where it crosses the x-axis, my first step is always going to be to find the gradient m of the radius. So let's draw on the radius. There is the radius. We're going to draw a right-angled triangle, and we're going to say that is a distance of 3 or minus 3, and this is 4. So the gradient of my radius, change in y over change in x, which is 4 over minus 3, or minus 3, sorry, minus 4 over 3, sorry. So that's the gradient of my radius, and that makes sense because my radius is downward sloping. My second step is I know that the radius and the tangent are perpendicular, so I need to take the negative reciprocal of minus 4 over 3. So it's going to be positive 3 over 4. Okay, my third step is to find the equation of the tangent, which I know is y equals mx plus c. I know what the gradient is. I know that the gradient is 3 over 4, 3/4. And I also know this point, xy, minus 3 and 4. So we're going to substitute all of that in. 4 equals 3/4 times by minus 3 plus c. Okay, let's multiply out. 3/4 times minus 3. You do actually have a calculator on this paper. So what did you get if you put that into your calculator? This is minus 2.25 plus c. And so if I add 2.25 to both sides, you get c is equal to 6.25. Therefore, I've worked out the equation of my radius. So y equals 3/4 x plus 6.25. Okay, that makes sense. The gradient of that tangent is positive. I can see that because it is upward sloping. And it also hits the y-axis, it hits the y-intercept at 6.25. That makes sense. Now, one thing I should have done on my diagram to make it a bit clearer, I'll do that now, is to draw on my x and y-axis. Because for my fourth step, now that I found the equation of the tangent, I can work out where it crosses the x-axis. Well, it crosses the x-axis at this point here that I'm circling. Now, what do I know about this point? What do I know about this point? Is x equals 0? Is y equals 0? Well, I think that at this point here, y is equal to 0 because it hasn't gone up or down in the y direction. So if y equals 0, I can substitute that into the equation that I've got here. So I can say 0 equals 3/4 x plus 6.25. Now I can find my value of x. So I can minus 6.25 from both sides. And now I can divide by 3/4. And I end up with x equals minus, as a fraction, 25/3. Okay, I end up with x equals minus 25/3, which is actually, as a decimal, I could write it as 8.3 recurring. So it's really close, sorry, minus 8.3 recurring. So it's really close to minus 8, but it's not minus 8. So my final step for my conclusion, let's use this purple. My final step, I'm going to say he is wrong as it crosses at minus 25/3, 0, not minus 8, 0. Okay, so that question became a lot easier once I drew the diagram and worked through the normal steps that I would do when I'm finding the equation of a tangent to a circle. If you got all the way to step 3, I think you would have got 2 or maybe 3 of the marks. You can check the mark scheme. But for that 4th step, where it crosses the y-axis, you need to realize that at that point, you know that y is equal to 0. Solve for x, and then that gave you the coordinate minus 25/3 and 0. Let's now go to the last question. Okay, done this all in one take so far. Let's see if I can finish it off with the last question. So this is the last question of the paper. It's quite a nice question. Lots of you asked me to go through this one, so I will. So there is a total of y counters in a box. Okay, so total of y. There are x pink and 5 blue. The rest are green. And I'm also told that x to y is 1 to 3. Freda takes at random 2 counters from the box. It doesn't say that she replaces it, so she does not replace it. Find in terms of x, an expression for the probability that Freda takes 2 counters of the same color. 5 marks. Right, so I got quite a lot of information here. What I am going to do, I'm going to start off with a bar model. Start off with a bar model. I'm just going to make it a little bit down. Okay, start off with a bar model. So what do I know so far? I know for a start, I'll use P for pink, that there are x pink counters. I also know that there are 5 blue counters. And the rest are green. So I think I need to come up with an expression for the number of green counters. I'm also told that there are y in total. Now, because it says in terms of x, I don't like having this y. I think I want to change this y to something which has an x in it. Now, if you look at this ratio again, it looks like x to y is 1 to 3, so y is 3 times bigger than x. So I can write, instead of y, I can write 3x. Now, can this help me with my expression for green? Yes, I can. This expression here is going to be the total 3x minus x for pink minus 5 for blue. So that is 2x minus 5. So green, 2x minus 5. Okay, so now we can go ahead and think about probability. So how many ways can Freda take 2 counters of the same color? Well, the first way she can do it is she can take a pink and then another pink. Okay. The second way she can do it is to do a blue and then another blue. And then the third way is to take a green and then another green. So if I work out an expression for all 3 of those probabilities and then add them together, I'm going to get my answer. Now, I'm actually going to start off with blue and blue because I think it's the easiest to explain. What is the probability that on the first pick, I draw a blue counter? Well, there's 5 blue counters out of a total of 3x. What do I need to multiply that by? The probability of taking a blue on the second pick. Now, I'm going to tell you that it is 4 over 3x minus 1. Can you work out why? Well, if you think about it, the number of blue goes down by 1 because I've already picked a blue, so there are now only 4 left. And the number in total also goes down by 1, so it becomes 3x minus 1. If I multiply these together, 5 times 4 is 20, and 3x times 3x minus 1, I can write as 9x squared minus 3x. Okay, let's now do it for pink. So, probability of getting a pink on the first one is x over 3x. And the second one, can you think about what it might be? X minus 1 over 3x minus 1. And I can simplify that. And finally, for green, green, I should have done the blue one in blue, but I did it in red. But I'm going to do the green one in green. So the first one is going to be 2x minus 5 over 3x. And if there's one less green counter, then I just need to subtract it by 1. So 2x minus 6 over 3x minus 1. And I'm going to use a box method to expand that out. So I get the right answer. So I got 4x squared minus 22x plus 30 over 9x squared minus 3x. Okay, so I'm almost there. I just need to now find the total. I'm going to add all of these terms together. So x squared minus x plus 20 plus 4x squared minus 22x plus 30 all over, because they all have the same denominator, 9x squared minus 3x. And I get my answer, 5x squared minus 23x plus 50 over 9x squared minus 3x. And that is my answer. So hopefully that makes a lot more sense for you. I'm glad I managed to do it in one take. I think that's the first time I've ever done that. So well done me. 38 minutes, not bad. As always, if you've got any questions about any of the other questions, then first of all, look at the mark scheme. Then see if you can find something else on YouTube, Maths Genie, Corbett Maths, to help you out. But then, of course, you can email me, and I'm very happy to help. Okay, see you tomorrow. Bye-bye.